All right, so first up, the first examples we do are going to be where we add and subtract things with like denominators. And let's do an example, and then we'll just go over the actual rule that we use. You should know how to do this without the assistance of technology. Say somebody asked you to add 2/3 and, I don't know, 7/3. Well, what is it? It is 3. How'd you do that? Yeah. When you have the same denominator, you just put the top pieces together is all you do. And you get 9/3, which is 3, as Brenton said. We'll just write the same rule down for both of these. A over B plus or minus C over B, doesn't matter which one you're doing, addition or subtraction, the property is the same, is A plus C sitting over what? B. It's A plus or minus C sitting over B. And that's just the property you use. Now, if you've been punching buttons on a calculator your whole life, you probably don't quite get that. Just goes back to 5th grade. Got a couple of easy examples in your notes. A and B here both have like denominators. Truth is that A is actually the harder one. Why is A the harder one? Subtraction, and it's not subtraction of one thing. Subtraction of two things. And that's where kids will make mistakes. You make mistakes on signs. And you just can't do that in math. So I'm just going to follow the property legit. And I'll show you what the typical kid does wrong, because this is what the typical kid does wrong. And it will be wrong. Why will that be wrong? It's got to be positive 5, you know. You got to remember that there's two things there. You've got to remember to distribute your negative symbol. You have to remember that. This has to enter. Daniel's right. That is a positive 5. So if you don't use parentheses, or you don't at least think about the parentheses, you're going to mess up. If you wrote what I wrote in the beginning on a piece of paper, you're going to miss it. Plain and simple. 2 or more, what do? You wrap. Combine your likes and the thing's done. You're in pre-calc, you don't know what 4x minus 2x is. You're in the wrong class, kids. I ain't here to teach that lesson. Although there are some Algebra 2 kids this year who are doing that. Bless them, isn't that what they say? Like the kid I saw the other day who still had a map of the school to get from class to class. Bless them. Been here 2 weeks. All right. You guys need to see B? I need to waste your time with that. What is it? Just verbally, what is it? Good, because if y'all didn't say anything, I was about to have you text me or message me, because that's all you're doing right now. Even Aaron the other day in study hall got on to somebody for talking to her. He's like, why didn't you just message me? She was in her bubble, and she didn't want to be bothered. She was busy. All right, next up, adding and subtracting with an unlike denominator. So let's just do an example with some numbers, and then we'll kind of think about what the property is. It doesn't matter if it's addition or subtraction. So our example numbers will be 2/3 minus 5/11. What do you have to seek out? You seek out a common denominator. How do you do that? There's a shortcut, isn't there? What's a shortcut? You don't actually have to think or seek out the common denominator. There's a shortcut to it. Yeah, in essence, yeah. This guy's got an 11 on the bottom. Put an 11 there. If you put an 11 there, what do you have to put up in the numerator? An 11. This guy's got a 3, so what are you going to put next to this 11? Another 3, as does this one, or as the numerator gets it as well. So that's kind of the shortcut on these, just multiply it by what they're missing. That's what I always did. Multiply one fraction. There's got to be an easier way to put this in words. Yeah, we'll write that down. Multiply each fraction's numerator and denominator. We'll say by what it is missing, or by what the other has. There's probably a more elegant way of saying that, but I'm not an English major. Then you can figure it out. Let's see, 11 numerator and denominator, we got 22 33rds there. And if we 3 the numerator and denominator, we got 15 33rds. And we're right back to the first thing in our notes. We have a common denominator. So what's the resulting fraction going to be sitting over? 33, right? For those of you who just suck at numbers, here's the step. We do 22 minus 15, and what do we get? 7. So 7 33rds. I don't actually always use this rule when I do it. I kind of use the verbal approach. Multiply each fraction's numerator and denominator by what the other has. I don't necessarily follow a rule. The rule here is if we have some A sitting over B, and we add or subtract some C sitting over a D, is that we give A, D. What do we give C? B. I probably made your class memorize this rule. And what do you do with B and D? Multiply them together. I actually approach things from a different, I don't generally follow that rule actually. I do things a little bit different, but that rule always works. I'm going to actually try to work out the next example following the rule and then going back and looking at the actual problem. Because you're going to get the same answer both ways, but one of them is going to be a lot less work. So when I do this one the first time, I'm just going to follow the rule. All I'm going to do is follow the rule. All right. What do I give 7x? 3x squared plus 3x. Plus because there's a plus. What do I give x? 9x squared. What's sitting over? Taylor knows what she's doing. And I guess most kids, if they were following a rule, they would just sit here and they'd kick in the distributive property. So we'll kick in that distributive property. 21x cubed plus 21x squared plus 9x cubed. Bottom, probably kick it in there too, even though you probably shouldn't. 21x to the fourth plus what? 21x cubed. So there's a legit follow the rule. There's a lot of work to be done with this thing. What's something they all have in common? They have an x what? I think I heard a 3. Did I hear 3? What else? X squared. All terms have 3x squared. What's wrong, Brendan? Yeah, 9 times 3 is 27, isn't it? I know that. Apparently I wasn't thinking it though, was I? Memorized my multiplication tables in what, 1984? It's a long time ago for y'all, isn't it? So what can we do with that? Can we pull it out or just cancel it out of each term? So we're going to divide each term by 3x squared. As long as we do it to everything, we're not going to break anything. So we divide, let's start here because it's the highest power of the numerator. We divide 9x cubed by 3x squared. What do we get? What do you get? 3x. Oh, sorry. I'm a little slow this morning. There's actually 30x cubed up top, isn't there? We divide 30x cubed by 3x squared. What do we get? 10x. We divide 21x squared by 3x squared. What do we get? 7. Go down to the bottom, repeat. If you divide 27x to the fourth by 3x squared, 9x squared. And what, plus 9x? Now, if you're doing IXL would reject this answer, and they should, because the bottom can be factored. That's kind of a deal. Always simplify or factor the denominator. Always factor the denominator. Now, if I was doing this problem, I would have simplified things from the get-go. I wouldn't have done it all at the end. For one, I made my job a lot harder in the process, and heck, even I couldn't multiply right apparently, or add things together. So I would have looked at it in the beginning and I would have done some work. You know, that's 7x over 9x squared. Can't you clean that up a little bit? What does 7x over 9x squared reduce to? I don't know if y'all are tired, bored, or just don't give a crap. X over 9x squared is nothing, huh? With a Q talks like that, could have figured it out. Come on, kids. Fine. I'll call on you. Emma, 7x over 9x squared. No guessing. Yes, you know. Hanukkah. Ooh, I was just poking fun earlier. Bless you. Daniel. Of course it's 7 over 9x. Kids, the x's cancel. These guys had an x in common, didn't they? If you have it in common, can't you just divide it out and be done with it? All right, let's try this again. Now we got x over 3x squared plus 3x. What's common? So you divide everything by x. What do you have left? 1 over 3x plus 3. Now, I know you have a rule off to the side. I wouldn't use that rule entirely. I wouldn't. Well, I guess you could. I don't know if I want to confuse you or not. I'll confuse you later. Let's just follow the rule for now. All right? We're going to give 7 3x plus 3. We're going to give 1 9x. And what's the unified denominator? 9x times 3x plus 3 is correct. We'll distribute in. 21x plus 21 plus 9x. Sitting over 9x times 3x plus 3. Now we've got 30x plus 21 sitting up top. And we got what? 27x squared plus 27x sitting in the bottom. If you just focus on the numbers 30, 21, 27, and 27, what do they have in common? 3. You can't say they all have an x, because they don't. So the only thing we can do is divide everything by 3. There's 10x plus 7. That looks familiar. The bottom is 9x squared plus 9x. Doesn't that look familiar too? You get 10x plus 7 sitting over 9x times x plus 1. So even the initial simplification still led to a little bit of work, which is still too much. It really was. What I actually like to do is I like to factor. That's what I actually like to do. I like to factor. And it'll make your life a little easier. I don't know if this is the example to show it on or not. But a lot of times if you'll factor from the get-go, things will start making a lot more sense. So think about that for now, and how you might use the idea of factoring as well. I'll save that for a different example. I've already done this one twice. I don't want to do it a third time. Maybe this one we'll think about it. Here we got x plus 2 sitting over twice x minus 2. Take away a negative 2x minus 1 sitting over x squared minus 4x plus 3. And I'll be 100% honest with you. This is where I would do this. Plus, plus, plus. Looks easier now, doesn't it? Think about distributing that negative in. I think it looks easier. So I'm going with it. Let's do your second favorite F word. Factor. Can you factor 2x minus 2? You can. How's it factor? 2 times x minus 1. How about x squared minus 4x plus 3? X minus 1 times x minus 3. Now, I'm not going to follow the rule on this one. I'm going to follow the verbal idea. Give each fraction only what it is missing from the other. Give it only what it's missing. Nothing more. Don't give it all. Give it just what it needs. It's a lot less work. So I start with this thing, x plus 2, 2 or more, going to wrap because something's about to happen to it. If I look at its denominator, it's got twice x minus 1. So I start looking over at the other guy. What is the only thing twice x minus 1 is missing that the other guy has? X minus 3. Just give it the only piece it's missing. Plus, because there's a plus. 2x plus 1 wrapped because it's 2 or more and something's about to happen to it. So I look under 2x plus 1. I see x minus 1 times x minus 3. I look to the left and I think, what's it missing? Missing a 2. You just give the pieces that you're missing. You don't have to follow the rule legitimately. You just have to give it what it's missing. When you do that, you're actually forming what's called the least common denominator. So forms what we call the LCD, which generally speaking means you don't have to simplify near as much. That's what it generally means. You do not have to do any more simplification. Sometimes you do, but usually you don't. Now, about all we're going to do is we're going to do what Jesus would do. What would Jesus do? FOIL. We're going to hit it with the distributive property. We are going to leave this factored. Don't touch it. Just leave it alone. And don't be the kid who writes this down and then cancels out x minus 3 and x minus 1, which I didn't write, did I? I didn't have to. Okay, never mind. Don't be the kid who cancels out those x minus 3s. So Jesus would FOIL this. Why don't you guys spend 30 seconds of your life FOILing? You at home too, if you're watching. Nobody from pre-calc that has been absent has yet to watch a video. It's kind of weird. Anybody FOIL that out? Sounds good to me. Just copying my plus sign down. 2x plus 1 times 2 being 4x plus 2. So over twice x minus 1 times x minus 3. And it's just like terms, kids. Looks like we have an x squared minus a 3x minus a 4. So then over twice x minus 1 times x minus 3. But wait, there's more. It doesn't happen often. This is a special example. Will the numerator factor? So factor. How's x squared minus 3x minus 4 factor? I swore to said honors. Sounds good to me. If you can factor, factor, because you might get lucky and you can do another cancellation. But can you do a cancellation here? So don't. But if you can factor, factor, kids. And there's a reason you do that. It happens later on when we start talking about the graphs of what these things look like. You need things factored to understand those graphs or to be able to graph them by hand. So you leave things in a factored manner. So that was a bunch of fun, wasn't it? Notice what it says. It says, I love this stuff. I do love this stuff because I love factoring. All right, here is a nested fraction. It's called a nested fraction because it's literally a nest of fractions. It's like a hornet's nest. Are you afraid of hornet's nests? Why? Why are you afraid of a hornet's nest? Because it's full of. So why would you be afraid of a fraction nest? It has a bunch of fractions. Which one are you more scared of? Yeah, because you can kill a hornet's nest. You know, there's spray for that. There's fire. I guess you could burn your notes, your homework, but you know. We can do this the classical way, the long way. Now I'll show you a shortcut. So the long way is really going to have us add these together first. If you see some fractions, add them together. Okay? So we're going to add these fractions together. We'll leave that 5 over x plus 4 the way it is. And what are we going to give this 1? This little guy right here. What do you give it? Give it an x. How about that 2? X plus 4. What's the common denominator of the denominator? X times x plus 4. I'll clean this up a little bit. This is kind of a simple example because I don't want to take this forever. If we think about doing the distributive property over here, we'll have 2x, and we have another x. That makes 3 of them. Twice 4 is 8. And I'm not going to clean up x times x plus 4. Not going to do it. Because I know the next step. And if I'm telling you not to do it, you probably shouldn't do it when you try and do these on your own either. The next step comes from the content that you were taught. What day? What's the day? Wednesday? Well, I guess Monday I talked about it. How do you divide one fraction by another? Multiply by the reciprocal. So 5 over x plus 4 times what? Just heard multiply by the reciprocal. So reciprocate. X times x plus 4 over 3x plus 8. A lot of you had started this lesson on Excel, or actually a lot of you finished the simplified lesson on Excel. Some of you guys were still playing catch up. What can we cancel? It says the x plus 4s. So what are you left with in the numerator? 5x sitting over 3x plus 8. That's the long classical way of doing these things. It's a very multi-step process. It takes several steps. And I'm actually going to make the next one a little bit harder, just to show you the quick way. I'm going to add something to the numerator. I don't know that I should. No, it's not. If there's one in your homework, you can figure that out. The quick way, does anybody remember? Because that's how I taught it in Algebra 2. Well, multiply every term by, not the common, the least common denominator. The least common denominator in this one's pretty easy. What's one of the denominators? What's the other one? Turns out that's the LCD. Everything's already presented to you factored. And I don't usually show a lot of work on a piece of paper. I just think about the distributive property. And I'm not going to show a bunch of pre-calc kids what's happening behind the scenes. Because then it wouldn't be a shortcut. When you distribute this x minus 3 times x plus, believe it or not, that's supposed to be a 5, into 3 over x plus 5, what cancels? X plus 5's cancel. We're left with 3 times x minus 3. Sitting over. Now I distribute that into the first piece of the denominator. There's a 2 up top. It's going to stick around. It ain't canceling. But what does cancel? So what's left? X plus 5. Plus, because there's a plus. 1, because there's a 1. But what canceled? So what's left? X minus 3. Then just kick it with the distributive property. You'll be done with it. Numerator is 9x minus 3. Denominator, we'd have a 2x and an x, 3x. Ha! You're right. Because I'm retarded. Did you not hear me talk earlier? That's my normal voice. See if I can fix this problem. Down the bottom, there's a 2x and an x, so how many x's? 3 of them. 2 and 5 makes 10. 10 minus 3 is 7. Can you do anything with that? If you think you can, you have to go home and you have to kill your cat. You can't throw these x's away. Are all 4 pieces divisible by 3? Can't divide out of 3. There's nothing you can do with that thing. It is done. It is as simple as it gets. All right? And that's it for your notes. Let me give you your homework. Well, it's not really homework. You're going to work on it in class tomorrow. But you might find that you have nothing to do today, which you probably will.